So guys, we're going to start Unit 3 today. And our first section is going to be about rate of change and slope, if you have heard those words before. But before we start, let's actually define them. So rate of change, our definition is going to be that it shows the relationship between two changing quantities. Shows the relationship. I'm going to write it down. Between two changing quantities. So your input is changing and your output is changing. Okay. Another example, or an example of this would be, what would be two changing quantities that we talk about? And we've used these before. So rate of change, an example would be your change in your dependent variable over the change in the independent variable. Okay, so it's the change in dependent variable over the change in independent variable, which should make sense. When we're talking about like miles per hour, that's a rate of change, right? And your miles would be your dependent variable, and the hours is the independent variable. Okay, so your rate of change is always going to be dependent over independent. And then we're also going to talk about slope. How many of you guys have heard the word slope before? Okay, it actually, slope and rate of change, for those of you that have not, are the same. So the slope and the rate of change of something is the same. The slope is just the graphical representation of it. So the slope is the rate of change on a line specifically. So slope and rate of change are the same thing, but in specific, it refers to a line. So in our example, let's put this in terms of graphical representation. Is my dependent variable, which axis is that on a graph? Is it the y-axis or the x-axis? The y-axis. So it's going to be your vertical change over your x-axis, which is the horizontal change. Okay. Okay. So for the first lesson, we're going to be talking about rate of change and slope, what they mean, how we can find them. So our rate of change, we've already done it, is the change in which variable? Dependent over the change in independent variable. Okay, so it's the change in the dependent variable over the change in the independent variable. We can also represent this using symbols. So in Greek letters, the letter delta, which looks like a triangle, represents the word change in math. So is your dependent variable the x's or the y values, guys? The y's. So we can represent this symbolically too by saying change in y, or delta y, over delta x, the change in your independent variable. And then off to the side, I'm going to do that symbol equals delta, which is the same as the word change. Okay. Oops. There we go. Okay. So in math, the triangle symbol is also the Greek letter delta, which in math stands for change. Okay. So what we're going to do for these first couple examples is I'm going to give you a table, and then we're going to find the rates of change using the table. So let's look at number 1, and we're going to do number 1 together. So number 1 is looks like a band, and we're marching, and the time that they are marching in minutes causes change in the distance that they march in feet. So let's look at that first question. What is the average rate of change of distance between 1 minute and 2 minutes? So here's what we're going to do. We're going to do the change in y over the change in x. So I'm going to write that. Change in y over change in x, just to remind us. So if I'm looking at between 1 minute and 2 minutes, these are my my x and y values. So I'm looking at those two points on the table. And to do my change in y, I'm going to subtract. So that's going to be 520 minus 260. So I subtract the y's over the change in the x's. Now here's the thing, guys. Your x's need to be in the same order that we listed our y's. So because I did 520 minus 260, I have to do 2 minus 1. Okay? So over 2 minus 1 equals, this is how I want you to show your work. 520 over 260, what's that give me? 260 feet. And 2 minus 1 is 1 minute. So the average rate of change is 260 feet per minute. Easy? Okay. Let's do the next one. So what is the average rate of change between 2 minutes and 4 minutes? So we're going to do the exact same thing. Change in y over change in x. My change in y, 2 minutes and 4 minutes. So I'm also looking at this part right here. And I'm going to do 1,040 minus 520, where the 2 minutes is. So I'm looking at these two. All over 4 minus 2. $1,040 minus 520 gives me 520 over 2. And a lot of students usually tend to stop here, but look at the word that it asks for. It wants the average, so that means we need to simplify as much as possible. So what's that going to simplify to? Any ideas? 260 feet over 1 minute. Okay. So my average, what do you notice? It's the what? It's the same. Why do you think that is? It's going up at a constant rate, which means it's what type of function? A linear function. Okay, so what I want you guys to do right now is do 2 and 3 on your own. Number 2, we have a turtle and he's walking and that chart represents his speed. Who wants to tell me what was the average rate of change of distance between 1 minute and 3 minutes, Jen? 3 what over what? What was his distance? Meters. So 3 meters over 1 what? 1 minute. Thumbs up, you agree. Thumbs down, you disagree. You guys awake? Sort of. Okay. What was his average rate of change of distance between 5 minutes and 7 minutes? Who wants to give me that one? What'd you get? Christian, what'd you get?
I got -500 feet over 1 minute.
You got what?
Negative 500 feet over 1
Negative 500 feet over 1
meter.
meter.
Oh, wait, no, that one.
Are we on the wrong one? Okay, so what'd you get for
3 meters over 1 minute.
3 meters over 1 minute? Thumbs up, you agree. Good. Okay. So what you should have done for both of these is take the distance and subtract it, and then put it over the x value subtracted, right? But they have to be in the same order. So then let's see what we got on 3. Who wants to share what they got for number 3? Emily, what'd you get? Negative 500 feet over 1 minute. And that was between 0 minutes and 2 minutes. And then who wants to share what they got for the average distance or rate of change between 0 minutes and 12 minutes? Christian. Negative 500 feet over 1 minute, right? Okay, guys, do you think if for linear functions the rate of change will always be the same no matter which points we use? Yes. And that has to do with the line. So we're going to, that is called the slope. So we're going to talk about the slope. So like we said, the slope was, is the graphical representation of rate of change, but there are some notations that we have to make sure that we are aware of. So we're going to first find the slope using a graph, and then we're going to talk about how to find the slope if they don't give you a graph. First thing is that the slope does have its own letter representation. Does anybody know which letter represents slope? M. So right in there, will you make sure you label M? So anytime we're talking about slope, you can use the letter M to represent slope. So there are lots of different definitions for slope that we can use. One is delta y over delta x, which we already know. Another one is delta y is the change in the y-axis. So that would be your vertical change, which we already talked about, right? Over delta x, the x-axis goes horizontally, so that's going to be over horizontal change. Okay, so another way of writing delta y over delta x is vertical change or horizontal change. Or if we're looking at the graph, the one that we all will remember for the rest of our lives is rise over run. Okay, so if I give you a graph and then ask you to find the slope, all you really have to do is count your rise over run. Now on this graph, I actually gave you points, but if the points were not indicated, you would just look for where the line goes through the grid, the cross on the grid. So for example, this would be one point that you could use. Does that make sense? So if the points are not indicated for you like they are in the notes, you can pick your own points by looking and seeing where the line goes through the grid marks. So this would be another one. It has to go right through the center of the grid mark, right? But we're going to use the points that they gave us. So let's look at number 1. So we're going to count our rise over our run, which means we have to pick 2 points. So right now what I want you to do is pick any 2 points on graph number 1. And circle them for me. Okay, so you might have picked 2 different points. That's okay. I'm going to pick this point and this point. If you pick 2 different ones, you're going to do the same steps that I am doing, just with your own 2 points. I like to go from the bottommost point and then count my way up. So put your pencil on that very bottommost point, whichever one you picked, and we're going to count how many spaces up we have to go to get to the next one. So for me, I'm going to go up 1, 2, right? So what is my rise? Positive 2. Then I go from that point over to the next point, and I'm going to go to the right 1, 2 spaces. So my run is also positive 2. What if I had to go to the left? It would be negative. What if instead of going up, I go down? Also negative. Okay, so you have to indicate if it's positive or negative. And this reduces to a slope of 1. So for number 2, I'll pick the closest 2 points. So I'm going to go from here to here. And I always start at the bottom. So my rise is actually up 1, 2 spaces. So my rise is going to be 2. But for my run, I'm going to the left, which means 1 space, which means a run of negative 1. But we don't really usually want to leave that as 2 over negative 1. We want to reduce as much as possible. So 2 over negative 1 reduces to negative 2. Okay, thumbs up. You got negative 2 as your slope. Fabulous. Okay, let's look at number 3. Number 3, I'm going to pick these 2 points. And I go from the bottom one, so I'm going to go up 1 space. So my my rise is positive 1. And then I'm going to the left 1, 2, 3 spaces, which is negative 3. And then similarly, I don't really like positive 1 over negative 3. I like to rewrite it with the negative on the outside because that's just typical of what we do. So the slope is actually negative 1/3. Okay. So if you didn't rewrite it right now, that's okay, but do rewrite it at this time because just typically in math, when we have a fraction with a negative, we rewrite the negative on the outside. Okay, thumbs up. You got this one right. Okay, how are we doing so far? Okay, let's look at number 4. So number 4, you can pick any 2 points. I'm going to pick this one and this one. So just pick 2 points and mark them right now. And we're going to count the rise over the run. So rise from my 2 points are 1, 2, 3. So my rise was positive 3. I don't have to go left or right at all. So what would be my run? Okay, so 3 over 0, which reduces to what? Emily.
It's not possible. It's going to be undefined.
Why?
Because you can't divide by 0.
Yes. Okay. We call that an undefined slope because are you ever allowed to have 0 in the denominator, guys? No, because fraction is the same as division. So, and we could also think of division as the denominator times what gives me the numerator, right? 0 times, it doesn't matter what you multiply 0 by, you're never going to get 3. Do you see what I'm saying? So 0 times 3 gives me 0. 0 times a million also gives me 0. So we call that an undefined answer. So this slope is undefined. Also, is this even a function? No, remember vertical lines are not functions. So if it's not a function, it can't have a slope. So she said, instead of writing undefined, couldn't we also do this? Yeah, technically that means no solution, not undefined, but I would accept either one. Okay? So then let's look at number 5. I'm going to pick this point and this point. What would be my run on these guys? How many up or down do I have to go? 0. What would be, or sorry, my rise. What would be my run? On mine, I'm going 2. What's 0 divided by 2? 0. 2 times 0 gives me 0. So you can have 0 in the numerator, you just can't have 0 in the denominator. Okay? So if you turn to the next page, these 4 little graphs kind of give you a summary of what's going on, so I want to read through these. A line with a positive slope, underline positive slope, slants upward from left to right. So remember, we read graphs from left to right just like we read letters. Positive slope, the graph should always go up from left to right. So I always think of it as like walking uphill. So here's my little man, and he's going uphill. Okay, that's a positive slope. So when you start calculating slope, and then graphing the line using the slope. If you have a positive slope, you should have a line when you graph it that goes up. If when you graph it, it goes up, but you calculate the slope as negative, you need to go back and check your work, okay? So this top part of this page is a really good summary of everything that we're going to be doing today. And if you ever get information that contradicts itself, you need to go back and check your work. A line with a negative slope, underline negative slope, slants downward from left to right. So I always imagine that as walking downhill. So here's my little man, and he's going downhill. A vertical line always has an undefined slope, and I kind of think of that as if my little man was standing on the on that vertical line, what's going to happen to him? He's going to fall off, so he can't stand on that. Blah, here's him dead. Okay, so he can't stand on the vertical line, so the vertical line has undefined slope. And a line with a slope of 0 is horizontal. So all horizontal lines have 0 slope. Because if my little man was walking on the line, he's just walking on flat ground, right? Okay. So this is a good way for you to always check your math against your graph. Because your math and your graph should complement each other. They should give you the same answer. So using either method, you should get the same thing. Okay, so please make sure that when you are graphing and calculating slope that they actually match. You can also calculate the slope using coordinates or points. And this is called the slope formula. I wrote this really big because I don't want you to forget it. I also suggest that after we fill it in later, you either put a box around it or circle it or highlight it. The slope formula is M, which is rise over run. And it's the same thing as change in y over change in x. So what did we do when we were finding the change in the y? How do you find the difference between the y's? What did we do with the table? We subtracted them. So we say y2 minus y1. And those little subscripts 2 and 1 indicate which coordinate which point you're using. Over the change in x. So x2 minus x1. Please notice that my y2 and my x2 come first, and then the y1 and the x1 come second. Okay? And then also notice right here where it says x2 minus x1 cannot equal 0. If it does, that gives you an undefined slope. Okay? So if you get x2 minus x1 as 0, your slope will be undefined. So here's how I do it, and then I'm going to give you guys a chance to do the rest. The little graph is just a little graphical representation of what's going on. So your change in y's over your change in x's, it's rise over run. When I am solving these, I always label which one I'm using as y or x1, y1, and which one I'm using as x2, y2. So look at number 6. Does it matter which one you pick? The answer is no. You can use either point as x1, y1 and x2, y2. I usually use the bigger ones as my second. Okay, so that 5, 10, I'm going to label that right above x2, comma, y2. Which will make 3, 6, x1, comma, y1. And then I just plug them into the formula. So I left you guys a lot of room. M equals y2. Ladies and gentlemen, what are we using as y2? 10 minus y1. What's y1? 6 over x2 is 5 minus 3. I expect you to show this step because I need to see what you're plugging in. If you are getting the incorrect slope from using this slope formula, and you don't tell me what you plugged in where, I'm not going to go through all the different possibilities to find it, to give you partial credit, so you have to show me. What's 10 minus 6, ladies and gentlemen? 4 over 2, and that does reduce to a slope of positive 2. So what I want you all to make sure that you are doing is reducing as small as possible. You are going to get fractions. You are going to get negative slopes. Do not try and make the numbers fit so that you always get a positive whole number. It will be incorrect. So you must always you do y2 minus y1 over x2 minus x1. They have to match up. Another way that you can quickly check is that right here I have 10 and 5, and 10 and 5 go together right there. So they have to go in that same order. Okay? I'm going to give you guys a chance. Work on 7 through 11 for me right now. We'll check the answers in just a second. For number 7, I'm going to pick 9, 2 to be my x1, y1, and my 7, 8 to be x2, y2. If you did differently, you're going to get the same answer, so don't sweat over it. So my slope is going to be 8 minus 2 over 7 minus 9. Come on. 8 minus 2 gives me 6. 7 minus 9 gives me negative 2, so I get a slope of negative 3. Okay? You should, if you did it the other way, you're still going to get negative 3. It's just that you'll have negative 6 over positive 2. Okay? But it's going to be the same thing no matter what. Number 8. I'm going to do x1, y1, and then x2, y2. So my slope is going to be negative 2 minus 0 over 3 minus negative 1. Please make sure that you put that negative 1 in parentheses. Guys, what's negative 2 minus 0? Good, negative 2. 3 minus negative 1. When I subtract a negative, what happens? It becomes a positive. So that's going to be 3 plus 1, which is 4. What does that reduce to? Good, negative 1/2. Is everybody with me so far? Okay. Number 9. I'm going to do, let's just go in order, x1, y1 over x2, y2. So that's going to be slope is negative 1 minus 3 over 4 minus 1. Negative 1 minus 3 gives me negative 4. 4 minus 1 gives me positive 3. So my slope is going to be negative 4/3. Can you leave it as negative 4/3? Yes, it's actually preferred. If you tell me that slope is negative 1 and 1/3, that's not very helpful in graphing. So you want to make sure you leave it as an improper fraction, just reduced as much as possible. Number 10. I'm going to mix it up again. x2, y2 over x1, y1. Just make sure you're labeling yours. It does not have to be the same labeling as mine. And then slope is going to be negative 3 minus 2 over 4 minus 4. Uh-oh. That's going to give me negative 5 over 0. So what is the slope here, guys? Undefined. That means if I were to graph this, these 2 points, they should give me a vertical line. Okay, and actually they do. Okay, and then the very last one. Let's do x1, y1 over x2, y2. So that's going to be negative 3 minus negative 3 over 5 minus negative 1. Subtracting a negative becomes positive. So negative 3 plus 3, guys, what does that give me? Good. 0 over 5 plus 1? Okay, what's 0 divided by 6? 0. So what type of line would this be? A flat one, a horizontal one. Okay? And then that is your undefined. All right? So that's slope. All in a nutshell. So we can find slope using a table or rate of change using a table. We can find slope from a graph, and we can calculate slope from 2 points using the slope formula. So please make sure that you circle, highlight, do something so that you remember the slope formula. You will not be given the slope formula. You will be expected to have it memorized. So please make sure that you know it. Right? So I would suggest that you highlight it, something. Okay?